Hey, welcome. Have you ever stopped to think about how all the tech in our lives, your phone, your search engine, actually understands what we're saying or typing? It really feels like magic, right? But it's not. It all starts with one single crucial first step, a process that happens billions of times a second every single time we interact with our devices.
It really all boils down to this one question. See, a machine doesn't see words and sentences the way that we do. It just sees data. So the big challenge is, how do we bridge that gap?
Well, to get from our messy, beautiful human language to clean, structured machine data, we have to do something we all learned back in kindergarten. We've got to break things down into smaller pieces.
And believe it or not, that process has a name. It's called tokenization. All it really is, at its core, is the act of chopping up a stream of text into smaller units. We call these units tokens. And these tokens can be words or characters, or even just parts of words. This is literally the foundation of what's known as natural language processing, or NLP. The best way to get your head around this is to imagine teaching someone a brand new language. You wouldn't just hand them a complex novel, would you? Of course not. You'd start with the absolute basics, the letters, then the words. Well, tokenization does the exact same thing, but for machines. Let's make this super clear. Take a simple sentence. Chatbots are helpful. Okay, so we could tokenize it by word, which would give the machine three distinct little pieces to analyze. Chatbots, are, and helpful. Simple enough. Or we could go even smaller and tokenize it by character. Now, chatbots becomes ChatBots. It's the same sentence, but we've broken it down in two totally different ways for the machine to look at.
Okay, so we've got these different methods for chopping up text. But that begs the question, why would you ever choose one way over the other? Well, it all depends on what you're trying to do.
So the two most common types are the ones we just saw. Word tokenization is probably what you'd expect. You just split the sentence by words. It's fantastic for languages like English, where we have these nice, clear spaces. But then you've got character tokenization, which is way more detailed. It's super useful for things like spell checking or for tackling languages that don't have those clear word boundaries. Right? So what's the big deal? Why go to all this trouble? Well, this isn't just some abstract technical exercise. This is the engine that's running behind the technology you are probably using right this very second.
In fact, I'm willing to bet you have used tokenization dozens of times just today without even realizing it. Let me show you what I mean.
Think about the last time you searched for something online. The moment you type in a question and hit enter, the search engine's first job is to tokenize your query. It breaks it down into keywords to figure out what you actually want, and then it matches that to the most relevant stuff on the web.
Or what about translation apps? They don't just swap words one for one. That would be a disaster. Instead, they tokenize sentences. They analyze the relationships between all those little tokens, and only then do they try to build a new sentence in the other language. That first step, the tokenizing, is what lets it actually preserve the real meaning.
And of course, there are voice assistants. Siri, Alexa, you name it. When you say, "Hey Siri, what's the weather like?" your voice first gets turned into text. And what happens next? That text is immediately tokenized so the system can understand your command and go get you the forecast.
But here's the catch. As incredibly powerful as this is, tokenizing human language is, well, it's not always so simple. Why? Because our language is messy.
Take a look at this sentence. I saw her duck. Seems easy enough, right? But wait. Does it mean you saw a woman physically ducking down to avoid something? Or does it mean you saw the bird that she owns? For us, the context usually makes it obvious, but for a machine, this kind of ambiguity is a massive, massive challenge.
And that's just one of the hurdles. As we mentioned, languages like Chinese and Japanese often don't have spaces between words, which makes finding the tokens way more complex. And then you get into all the weird stuff, like punctuation, website URLs, or email addresses. How should a machine tokenize johndoe@email.com? Yeah, it's not as simple as it looks.
So if language is this messy and complicated, how does any of this stuff work at all? Well, luckily, developers don't have to start from scratch every time. They get to stand on the shoulders of giants by using some really powerful toolkits.
Let's talk about some of the heavy hitters. You've got NLTK, which is kind of the classic, the old reliable toolkit for deep linguistic tasks.
Then there's Spacey, which is modern, super fast, and built for huge real-world applications. And then you have total game changers like the BERT tokenizer. It's context-aware. That means it doesn't just look at the word duck by itself, it looks at the entire sentence at once to figure out if we're talking about a noun or a verb. That's a huge deal. That ability to see the whole picture is what makes modern AI so incredibly powerful.
So we've seen how machines learn to read by breaking our language down into these little pieces called tokens. But that just raises an even bigger question, doesn't it? Once the text is in all these pieces, how do machines actually learn what any of those pieces mean? Well, that is a story for another time. Thanks for joining me.